Welcome to the Foundations of College Algebra course. I'm super excited to get the semester started. We'll begin with the second module in Lumen, and we'll look at the language of algebra and how we're going to simplify and express algebraic expressions. So the first thing that we'll come across in the language of algebra is a definition called a term. So a term could be anything that you see inside of an algebraic expression. So for example, if we have just the expression 5, the term here is 5. Or if we have 5 plus 4y, then we have two terms. We have 5 and 4y. If we have 5 plus 4y plus 3x, then we have 3 terms total. This whole thing is called an algebraic expression. So algebraic expression is the whole thing, and then we have 3 individual terms. Now, inside each of these terms, I'll go ahead and list them out here: 5, 4y, and 3x. Each one of these terms is called something different. So the term that has no letters or anything attached to it, it's just a number, that's called a constant. So in 5 plus 4y plus 3x, 5 is the constant term. And then we have the 4y and 3x terms. Each one of those has a letter attached to it that represents an unknown. The letter itself, so the x and the y, those are called variables. And the part of the term that is not the variable is called the coefficient. So in this case, 4 and 3 are the coefficients. So the coefficient for 4y, the coefficient is 4, and the variable is y. And then in the 3x term, the coefficient is 3, and the variable is x. So overall, the constant term is 5. We have the 4y term, which has a coefficient of 4, variable of y, and then we have the 3x term, which has a coefficient of 3 and the variable of x. The entire thing, 5 plus 4y plus 3x, is called the algebraic expression. And then the next thing to know about algebraic expressions is how to combine like terms. So we'll move on to that. So combining like terms is simplifying the expression. So if I tell you, if I ask you to go to the store and pick up 3 plus 3 apples, that would be kind of a weird request. Normally I would tell you, just go pick up 6 apples, right? Because 6 is the same as 3 plus 3. In the same way, we can simplify our algebraic expressions by combining like terms. So let me give you an example. If we have 3x plus 3x, and I want to simplify this, instead of saying, 3x plus 3x, we can write this in a more compact way, more succinct way. It's the same way as saying 6x. And the way we actually do that is we have 3x plus 3x. We factor out the x, like this, and we do 3 plus 3, which is 6, x, and then we just put those together, since 6 times x is the same thing as 6x. Now, it's important to understand the differences in the terms. So if I give you a term of 3x plus 4y, 2 terms, so we have a 3x term and a 4y term, we're not able to combine those two things together. And that is because we have 3 lots of x's and 4 lots of y's. X's and y's are independent of each other, so we can't combine them. This is the same thing as me saying go to the store and pick up 3 apples and 4 oranges, there's no way to simplify that any further. I can't say go pick up 7 of one thing, right? Because that wouldn't be the same thing. So this expression is actually already completely simplified, whereas let's say this expression is not, because 3x plus 3x is redundant. We could just say 6x, whereas 3x plus 4y is not redundant because those terms are independent of each other. Now, let's actually start combining like terms to see what that looks like. So let's say we have 3x plus 4y, just like we did before, plus 2x. Now in this expression, let's go ahead and identify our terms. The terms that have x's attached to them, we have 3x and we have a 2x, right? So I'll go ahead and write down their coefficients as 3 plus 2. And then the terms with y attached to them, we just have a 4. So now let's go through and simplify. 3 plus 2 is 5, and then 4 is just 4. So in total, we have 5 x's and 4 y's, right? This is, if we go back to the apples and oranges scenario, this is like me saying, go to the store, pick up 3 apples, 4 oranges, and 2 more apples. Well, I could just say go pick up 5 apples and 4 oranges, right? So all we're doing are extracting the coefficients from the terms with variables and adding them together. Let's go ahead and look at another example. We have 5 plus 6x plus 4 plus 9y plus 12x. So the first thing you'll always do is go through and identify your variables. So let's identify the different variables we have here. We have an x, so I'll do the term with the variable. We have 6x, and we have 12x. And then we have 9y, and then we don't have any other y's. And we have, in the constant terms, because you can combine constant terms as well, we have 5 and 4. So now let's go through and look at each one of those. So I'll begin with the constant terms. So constants, I'll just identify as a 1, since it could be any multiple of 1. It could, the constant terms you can multiply by 1 and it's still the same thing. So we have a 5. I'll go ahead and cross it out whenever I use it. And we have a 4. And then we can identify, looks like x's are the next ones. We have 6 x's and 12 x's. And I'll go ahead and add these up now. 5 plus 4 is 9. 6 plus 12, 18. And then we have 9 y's. We'll just move that over. So altogether, we have 9 ones, right? I could write that as 9 ones, but we don't actually need that 1 there. It's kind of implied, so we'll just not use that. So 9, and then we have 18 x's and 9 y's. So we took this algebraic expression, which was really long and kind of confusing to look at, hard to keep track of where all the variables are at and what's happening, and we simplified it to 9 plus 18x plus 9y. Because overall there were 9, the constants added up to 9, the x's, there were 18 of them, and for the y's there were 9 of them. I think it would be helpful to go ahead and do another example of this, just simply because they can look different and they can be a little bit challenging sometimes. So I'll go ahead and do another example. Let's see, so we can do, we'll do a more involved one where maybe it's 2 and a half plus 6x plus 4y plus 7xy plus 3 plus 4x plus, let's say, another xy. So looking at this, it can look very daunting. There's a whole lot of terms in here. So we need to simplify this to make our lives easier whenever we're trying to read this. So first, let's go through, we're going to go through and review everything we've learned so far. The terms that we have, well, actually, we'll look at the terms at the end. That way they're all in simplified form. And I guess we'll go ahead and do the same thing with everything else. We'll simplify this first, and then we'll look at the terms and the coefficients and the variables. So for the constant terms, it looks like we have, and let me color code this. For the constant terms, we have 2.5 and 3, and those are the only constant terms I see. So 2.5 and 3. Together they make 5.5. Next we'll do the x terms, which looks like we have a 6x and a 4x. Note that we're not doing 7xy because it depends on both x and y. Whenever it depends on both x and y, or if it depends on multiple variables, then the multiple variables gets its own category, and I'll show you that in just a minute. So looking at the x terms, we have 6 of them, and we have 4 of them. That gives us 10. All right, looking at the y terms, we got 4y. Again, for the same reason as x, we're not going to include 7xy. It looks like y is by itself. I think in all of my examples so far, y has been by itself. It doesn't have to be. These are, of course, just placeholder variables. These variables could be A, B, C, it could be Greek letters, it could be anything other than numbers. It doesn't have to be just x and y. Those are just the convenient ones that I'm using. So we have 4 y's. And then, let's see, I'm out of colors here, but I'll go ahead and do this one in, I guess, black. We have 7xy and xy. So our xy terms, we have 7xy's, and we have 1xy, right? So for variables, I didn't mention this earlier. I'll make a little section out here. If I just have x, that is the same thing as 1x. So if I say, go get me an orange from the store, that's the exact same as saying, go get me 1 orange from the store, right? So we can just drop the 1 since it's implied there. So we have the 7xy's, and then we have an additional xy, which we can kind of fill in the 1 out front. So we got 7 plus 1, 8 xy's. So altogether, we can simplify this expression as 5.5 plus 10x plus 4y plus 8. So we took this very confusing, I'm sorry, don't forget about your variables, 8xy. So we took this very confusing expression, the 2.5 plus 6x plus 4y plus 7xy plus 3 plus 4x plus 1xy, and we turned this into a much simpler expression of 5.5 plus 10x plus 4y plus 8xy. There are no redundancies here. All of the variables are combined. We call that combining like terms, and this entire process is called simplifying the algebraic expression. And that will do it for this lecture. I'll see you all in the next one.